this site better when viewed with ganja? Please, click on the ganja.
That's a nice video of this. Huh? Blew out my flip-flop, stepped on a pop-top, cut my heel, had to cruise on back home. But there's booze in the blender, and soon it will render that frozen concoction that helps me hang on. Wasting away again in Margaritaville, searching for my lost shaker of salt. Some people claim that there's a woman to blame, but I know it's my own damn fault. Can't quite remember the second verse of that.
Hello everyone, welcome back to the laboratory. This is Twinbeard, and I'll be showing you some more things related to the FlowerPower device. But first I wanted to show you this Imatep fan that's originally a 2.3 amp 12 volt fan, and it's humming along very nicely, charging this this large gel cell radio. It's about a 110 amp hour gel cell. Here's your standard monopole. With the addition of the gearing switch here, we're using mu metal for the core of the coil, and this is a switch to kick on our condensers, which can break open a battery if we get a really bad battery. Like I put the voltage on this one when I started, it was 5.94. So if you throw the radiant spikes directly into this, you'll see a lot of those radiant spikes still showing up in your neon. What I found is that by engaging a larger condenser in parallel, it'll turn that into current, suck it up so you're not wasting that, discharging it as light, and it'll break open these batteries quite a bit faster. I've changed things up a little bit here so you can see a little bit better. We still have our ammeter right here, but now here's our scope. So working on the directionality of the lightning here to make it the best for everyone. Bring the intensity down here a little bit so it's easier to see for you guys. So here we're operating at a really low frequency. This is our starter device, as I said, and this one I call the flux transformer. It makes a big B field, I'll just put it to you that way. That's a bifilar starship sandwiched around the little Radio Shack spool, nothing in the spool. I had to put a tertiary there. We've got another single filar starship, and that's in series with the power, or the drive coil. So that was my first one magnet, no bearing Bedini, and I enjoyed it so much that I made a couple more. I wanted to show a couple of people how easy it is to secure these magnets. This is just a piece of PVC pipe, a 1-inch piece of PVC pipe. I cut that to size, and then I put a zip tie around it, and it holds it in there pretty well. So I'm going to go ahead and pull that magnet out of there. I'm going to shut both these other motors off because I want to lower our noise level as much as possible here. Other than the ambient background sound from the music, which I kind of enjoy, and you probably will too. Okay, so I've just got this little thing holding our rotor in place. And what I want to kind of show you Sorry, looking for an ergonomic space there to be able to show you this at once. I got the base resistance way down, so hopefully the microphone in this camera, wherever it is, will pick up me moving the base resistance up. As you see the scope trace. Just turning the knob at this point. And we're set at 0.5 microseconds there. So we started out at about 2,000 hertz. We're at 0.2 now, so that's a little less. How I'm making that calculation, by the way, for those of you. 0.2 milliseconds, I'm sorry, earlier. 0.2 milliseconds equals 5,000 hertz because, if you have 0.2, a known wavelength of 0.2 milliseconds in between each of these divisions, then any wave displayed there will have that known period of 0.2 milliseconds. That frequency translates to 5,000 times per second, or 5,000 hertz. So it looks like we're taking 6 hertz here, or 6,000 hertz, something like that. I'm going to drop it down and see if I can tune it in on 5. So that's pretty close. There we go. We're getting pretty close to 5,000 hertz right there. Pull it up. Okay, now I'm going to show you a couple different coils here concerning the peripetia effect. This is my revisited coil from the back of the television. This is the Gaussian coil off CRT. So we're set at about 7,500 hertz or so. We're moving at somewhere around there. So what I'm going to do now is I'm going to short this coil. And we get an audible increase in the sound. And we'll notice our scope trace moving. So we have audible representation and visual representation of the acceleration. Now, here's what happens when I lower the base resistance or lower the frequency this is operating at. The trace expands to the right, okay? Here's what happens when I increase the frequency. With the base resistance, it contracts to the left. So I'm just going to short this coil now. And with any luck, you can hear the frequency this thing is moving at. Unshorted. Now I'll short the coil. So you can see the parasitic capacitance is delaying it between 90 and 180 degrees out of phase so that it can actually kick us forward a little bit instead of slowing us down. We're phasing lens out. I'm an awful punster. You'll get used to it. Okay, so there's our rotor. I'm going to go with kind of a part 2 here of the startup process. So, and by the way, here's our schematic. This is also posted on the energetic forum on the One Magnet No Bearing Bedini list. Yeah, so when I go to engage my generator coil, what I'm going to do is I'm going to take this little tab here, I'm going to slide it in the middle of the coil, and I'm going to try to position the coil so it's top dead center over the other coil. Then I'm going to grab a alligator clip. I'm going to pull it up to the edge, and I'm going to kind of clip it on there with the alligator clip to hold it steady. And now I'm going to try to focus my magnet over top dead center over the center of the coil there. Okay, I'm going to connect our bridge rectifier over here. So I'll make a movie for my family back home.